what problem did we solve by moving over to linked lists as opposed to having arrays?
Minimum the space of the cycle.
What do you mean this?
Means by adding the linked list, we can we can show the minimum list, and other can be stored in the rest of the data.
Okay, so we could show a list of a list of 0 things.
Yeah.
And then as we add things, it gets bigger and bigger and bigger. But we didn't have to do that hack where we filled up the entire array with stuff and said, okay, well, we're going to cap this at 1,000 and that kind of stuff. Okay. Now there are linked lists built into Java, but we're not allowed to use them because we wrote our own, that's fun, right? That's what the cool kids do. So let's review here quickly. So the homework assignment was implement linked lists for credit cards, implement linked lists for loyalty programs, update your array adapter for each of those to support the linked list instead of the array of loyalty programs and credit cards. And is there any other piece of that? And then have it show like a 0 list and stuff gets added to it, right? We haven't done any Firebase stuff. That's tonight. Okay. Good. All right. So linked lists for both of them. Custom array adapters for both of them. Have the list view show. Go ahead.
Does the linked list also, does it take longer for, like, if you have a lot of stuff, since it's having to load as you go, is that actually slower or is it actually faster?
Well, let me quickly look here and see how stupid of a question that is.
Okay. You have to stop the recording, that sounds stupid.
Yeah, stupid question. Stupid question. Last time we talked about arrays being relatively fast because they're in contiguous memory because we could just mathematically compute where bucket 7 is, right? Where a linked list, these guys are relatively slow, but they're memory efficient because we have our stuff kind of strewn about memory, right? So if I want to get to bucket 7 of a linked list, I have to start at the beginning and then take 7 pointer-sized steps to get to the right place in memory where bucket 7 would live. So that is the trade-off. So your question about is it slower? It absolutely is slower, but that doesn't mean it's worse. This kind of comes back to a lot of our debates with technology today. Plenty of our most popular programming languages, like Python, for example, is an interpreted, loosely typed language, which is substantially slower than a language like C or C++. Yet Python's among the most popular languages today. Well, why? Our computers are really, 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 really fast. So who cares if a language is technically slower if 99% of the stuff you do with it is going to be instantaneous from a human being's perspective? It doesn't really matter. So, if we think about kind of the heartaches we've had the last couple of weeks with having our kind of our 1,000 bucket arrays and having to internally kind of keep track of how many things we actually have in there and having placeholders and stuff like that. Linked list solve all of those problems for us. Does that make sense? Because we can now have just an arbitrary size list. We don't have to know how many things we're going to store in it initially. Go ahead.
So I had a question, Java question. When you extend a class and then you're using the super constructor, that just says, okay, I'm going to use my parent's constructor when I call super, give it these parameters. In your credit card adapter for linked lists, was that necessary for us to do? That was the question.
I don't necessarily know. I'm guessing no. I'm guessing we could have done it without that. But because we didn't write, so here, let me just show you the example here. Array adapter, let's go this route. All right, so here's our array adapter for Android. So I'm going to show you the inheritance model for this guy. So an array adapter extends a base adapter, which extends object. So if I were to draw a picture of this, so we have object. All right, and that is something that's built into Java. Okay, then we have this thing called base adapter, whatever that is. And we're going to say that's green because Android's green, right? So that's base adapter. Then we have array adapter. Okay, that's also built into Android. That's why I made it green. And then what did we call ours? Like credit card array adapter for linked lists. That guy?
Huge. That was hard to type. Yeah, like there was
CW.
Wait, what is this?
Sure.
Oh, yeah. Credit card array adapter for linked lists.
I know a vendor you can work for, Dr. Lemon.
All right, we wrote this guy. You want to make it blue?
Yes, I
All right, so we'll make it pink.
So beautiful.
All right. So was that magenta?
Sure.
Is that what that color? Well, you're like an arty fartsy person, isn't that
I
magenta?
don't use the word magenta. Yeah, I just use pink.
Yeah,
Shut up.
that's an official term. Scientific. Sometimes I wish I was artsy fartsy. My interfaces look terrible.
But you got red and pink on your slide.
That's bad?
Yep.
Interesting. All right, so we wrote this dude, right? So this is now we're answering your question. We wrote this guy. We didn't write this guy. We didn't write this guy. We didn't write this guy. So this is the inheritance model that we have based on our credit card array adapter dealy flippy thingy. So we wrote this guy in terms of this guy, which is written in terms of this guy, which is written in terms of this guy. We don't necessarily know the implementation of array adapter. Now, we could experiment with it and try to figure out how important it is to use the default array adapter constructor. Like, does it do some sort of magical stuff inside for setting some things up or not? I happen to know a little bit how it works. The short answer is the most convenient thing for us to do would be to use the array adapters constructor because that will automatically go ahead and set its local variables for those things, as opposed to us then having to call the setters for it to set up context. Although context wouldn't be necessary based on what we're doing because we overwrote GetView. So we're the ones who would be using context, so we wouldn't have had to set that. We would have to set the list. The way it's working for, originally, before we did the linked lists, we would have had to set the array with the constructor because it then calls the count, and that was the thing I think I told you that there was a little trick to it where we had to also override the, get count or size or count, whatever the function was called on the array adapter to advertise how many elements are in your collection. And then the last thing is the ID. So really, it's most convenient if we do call the parent constructor. Because if we don't, let me just show you the pieces here. So is this the guy? Yeah. So here's the constructor call here. So, you see I called a little bit different version of the constructor. Okay, I called one that takes in a context as well as the resource ID for the row. I didn't have it take in the list because I kept track of who the list was. All right, but bottom line is this GetView will automatically have that resource, that view passed in. And that dude is built in terms of this text view resource ID. Okay. So we kind of need to have that. Okay. So the answer to your question is no, we don't have to. But in this case, it was probably more convenient. Because if we had not done this, we would have had to do something like this dot set. Is there not a setter for it?
Is it just pointing something to the view that was passed in?
Yeah, it's called this dot m context. So we could have said this dot m context is equal to context, and that would have set up that variable. You know, so we had to do a little exploration to find out what that guy named his variables and things like that.
Yeah, I was curious because of the fact that these are overloaded procedures. I was just
Oh, m context is my guy.
how do you choose which super to use? Because like that was the thing is like, you know, I tried to do it from scratch where I just right clicked and said, okay, build my constructor, and it like
Yeah.
gave me options. I was like, I don't know which option I care about.
Yeah, I mean,
So I'm glad
it's
you
the
did
one
it
that makes the
right.
most sense for, I mean, most of the time when we write classes, we're going to have one or two constructors. But as you see, with objects that are built into the language, there might be 15 or 20 different ways you might build that particular object. So, you know, you use the constructor that makes the most sense for what we're doing here. In this case, since we're storing our own unique style linked list instead of a built-in collection type,
I understand why we're overriding it. It was just
but this specific one, I'm overriding this specific one because I didn't want to provide it with any sort of collection type because Java is not going to view this guy as a default collection type
I see.
because it's my own custom linked list. If I had used Java's built-in linked list type, then I could have used the default array adapter constructor and passed that collection, and it would have been cool with it.
Okay.
So that's the punchline with that guy. So
So if you'd instantiate, oh yeah, no, it makes sense. I think my question's answered. I wondered, I was like, you have like the list of T or list object or something like that of default constructors.
yeah, you could actually implement that interface to make sure it has the methods that all collections of things, iterable, I think they're called iterables, have that would make it work with the default array adapter.
Okay.
But I just wrote a generic linked list. All right, so this is what differed this week from the previous weeks. So our array adapter for linked list still took in a context, still took in our resource ID, took in our unique collection of stuff, so linked list of credit cards in this case, and then we'll have to duplicate this for loyalty programs. I'll go ahead and have array adapter. This guy is a array adapter, so I'll go ahead and have him just do his initial building. Whether or not that's absolutely 100% necessary is negotiable, let's say, but at some point your GetView is going to need to be able to get his view from somewhere. And actually I inflate it on here. So the way this is currently running, I think you actually could omit this. Oh, what is this guy? Oh, interesting. Okay, so let me expand on my answer to your question. Notice when I don't call this, and when I don't say super here, what it tries to do is an imaginary that. Okay, we don't see it, but it's kind of an invisible version of that where it's calling the parent's constructor, passing it no parameters. Now, the presumption being that it needs to create the parent instance in order to create this instance. We need to have all the stuff from the parent. So the issue here is, though, if I take this out and you look at the error message, it says array adapter doesn't actually have a constructor that takes no parameters.
Yeah, I see what you're saying. So if we tried to say super just context, maybe that would be one of the polymorphic.
Yeah. There's if we look in, we can just look at it real quick. So here's array adapter. Here's all the constructors. So here's one that takes a context and a resource.
Like the most basic one in our.
Yeah, looks like it.
So.
Which one? What is the default one?
Well, the one we used before was this guy.
Okay.
If we were using one of Java's built-in linked list stuff, we could actually use this dude. But ours isn't a built-in linked list stuff. Ours is our own custom brew. All right, so I used this guy up here and said, look, here's the context, here's my resource ID. I'm going to handle all the stuff dealing with lists.
So you called this, you constructed the most basic array adapter that is allowed by the parent.
Yeah.
Okay.
But had I not tried to do that,
Sure, I get what you're saying.
yeah, right now it is trying to, we don't see it, but it's trying to do this. And one of those doesn't exist. Yeah, so it's trying to do whatever it can to instantiate the parent, so we have that guy. So with that in mind, even though the reality is we didn't have to call the parent's constructor necessarily for the setup, we do need to call the parent's constructor in this case because there isn't a no argument one that will by default get called.
Got it.
Okay.
So look at the documentation.
Well,
The story. You have to know how the parent works.
yeah, but I think the more important lesson there is instead of like just looking at the documentation for an individual array list or something like this lesson translates into all other objects. Yeah, yeah. No matter what the object is,
It's going to call super.
it's going to call super to build that parent relationship. So to make this hierarchy. This guy is one of these, which is one of these, which is one of these.
So when you instantiate an array adapter, instantiate something from base adapter.
It'll call super on base adapter.
And call super on object.
Yep. Okay, so we build our default credit card adapter for linked list things. We took in the exact same stuff we took in before, except instead of an array, we took in our special homebrewed linked list dealie. All right, we went ahead and let array adapter do some initial building of itself. Then I set some local variables myself. This is likely redundant because I can actually say super.getContext. That would have allowed me to get the context that was passed in from the constructor here. So array, this guy is an array adapter. Array adapters have a getter for their context. So I could actually say this. Instead of setting mContext equal to the context that was passed in, I can say super.getContext there if I wanted to. They'll be synonyms because I pass the context into the parent constructor, which then sets the array adapter's parent's context, and then I'm saying, parent, give me your context, which will be the same thing as this guy right here. All right, but this is redundant. I didn't need to do that. Okay, so if we really want to strip this thing down, so why don't we go ahead and do that just as an exercise here. So I'll go ahead and I'll just not locally store the context.
See, yeah, and that's why I was confused by the super call, because I was like, we're using the same parameters. So
Yeah.
it's like, why are we doing this twice?
Yeah, so I'll go ahead and not locally store that, and then I'm assuming super dot get well, I already got context. I'm looking for the view resource ID. I don't see a way to get the resource ID. Oh wait, actually it passes, doesn't it pass it into this guy? Or it passes a, no, it passes a view. Yep, I don't see a clean way of getting, so it's super dot. Be something that returns an int. Nope. So I do need to still store my resource ID here for building that guy. At the very least, I mean, we know array adapters are storing that, but it doesn't make it public and it doesn't give us access to it. So I can get away without storing the context because I can get at the context from super, but I still need to store the resource ID. So then down here, notice this guy's complaining now, but I can just say super.getContext, and there's my context for that guy. All right, so let's walk through this. All right, so building my array adapter, storing the couple of things that I care about, so my linked list of credit cards and my resource ID, so I can inflate that if I need to. All right, this was the special guy that I had to write that I mentioned before, because a array adapter needs to be is going to poll itself for the current count for its collection. And before, when I built our default array adapter, when I passed in an array, it would have getCount would have returned the array's length. Similarly, when we built our custom array adapter last time, this dude, notice when I built the constructor for this dude, I still passed in the array to the parent's constructor, to the array adapter constructor. So his getCount would already be able to return the length of that array. So what I changed this time around is because I gave it this foreign object, something it doesn't know about, my invented homebrewed linked list, and I did not pass that guide to the parent's constructor. Get count would have no way of, it doesn't know how many elements you have in your list. So I had to override this to make sure that get count produced for me the integer that is equivalent to the actual number of elements in my linked list. That make sense? Okay, because the array adapter polls itself for how many elements do I have so that it can call GetView the appropriate number of times. Make sense? Those two pieces? All right, so this was kind of the tricky piece there, even though it's not very much code. Without me going over that last time, that might have been kind of a stumbling place where you're like, okay, well, it's never actually getting its count. You could have probably hacked it by passing it like an array and just kept changing the size of that array to match the size of your linked list, and it would technically work, but that would be the wrong way of doing it. This is better. Okay, so I overrode the default one just to return the number of elements that are currently in my linked list.
What's the non-null?
Where?
What's that?
Oh, that this guy, I think you could actually probably omit it, but GetView is a function that never returns null. It must return an actual view.
Oh.
And we police that inside of here. We talked about this before where so this is the presumed row, right? So this is the presumed already inflated row that gets passed into this. And notice that this guy is flagged as potentially being null. All right? We talked about it last time. Why might a row be null when it gets passed in here?
Well, if it's not like just a normal view, like a string view.
No, as far as we're concerned, our list views are filled up with a whole bunch of identical rows,
You
right?
said it's a memory efficiency. So if you have like a list view with 1,000 elements, but you're only showing 20 at a time, why inflate all 1,000? You're only going to inflate 25.
Okay.
That,
So when would this then be null? Well, that's the definition of it being null. Under what conditions would this actually be null? GetView gets called every single time a view is about to appear on the screen, right? When would the actual view, so this guy is our row. That's what that view is. It's the row that we're going to fill in. When would that actual view be null?
It's empty.
Well, I'm guessing you're wrong, but go ahead and explain more.
I don't know. That's all I got.
so anyway, I thought you were saying that like, so it had to do with the spinner. I guess that's not the right way to put it. So if you have, the spinner is full of these views, but this is how we stuff them into the view, isn't it? This is how we put them.
Is it full of those views when it first comes into existence?
No, empty.
So the very first time that we generate our rows,
Yeah.
this is going to be null,
That's right.
right? So you mentioned like we have 1,000 rows, but we're only showing them 20 at a time. The first time we go to get our 20 rows, our very first 20 rows, or the very first row, this is going to be a null value because we have not inflated that reusable row yet. So there's an efficiency thing where once I inflated my 20 rows or maybe 24 rows or something like that, so you got a couple that are off the screen, as we start scrolling through there, we're going to recycle rows that have already been inflated. So it's going to actually be a view, and I'm just going to swap out the information on it and reuse it. But the very first time that our app launches, and we have 0 rows that have been filled in, this guy is going to come in as a null value. I don't have an actual row yet. So that's what this first thing says.
So will there be as many rows as there are elements in the linked list? Or
There'll
is that the
be,
efficiency thing?
that's the efficiency thing.
So
There will
it's
be
gonna-
as many rows as their internal efficiency says needs to be created in order to give you a smooth
for
scroll.
the viewport to work.
Yeah.
Okay.
So if you have 1,000 rows, maybe it's 24 actual rows that are ever created, and
So
those
that's
just
what
get
I had to
reused.
you got to make a distinction between the row, the layout row, and the linked list item. They're not synonymous. The layout is just a holder for information.
You mean the layout ID?
No, I'm sorry. I'm thinking of custom credit card row because that's what's getting inflated, right, in the list view?
Correct. Yeah, but that's related to this. That's the ID of that guy.
Yeah.
So
you're going to have X number of that, even though you have Y
if we
number.
presume that there's going to be 24 actual views for the representing the rows, even though you might have
And
1,000
it's gonna pull
things,
elements in and
the
out.
first 24 times this guy gets called, this will be null.
Okay.
Because we haven't actually created those views yet. That efficiency thing says we are only going to create a view if we don't currently have a view. So in that example, the first 24 times, we'll ask the question, is the dude that was passed in, is it null? If it is, we'll go ahead and bring the clown in to inflate it. He's going to inflate it in terms of the context owned by this array adapter. What's he inflating? He's inflating the view described by this view resource ID. And he's doing it inside of, in this case, this will be our list view in our example right here. All right, so the first 24 times in my little example here that this guy gets called, we will get into this if statement and actually blow up that view and give ourselves an actual view. Then we go and grab the individual little pieces from that, that view. So my name, text view, all that stuff. Then I go ahead and grab the credit card from a certain position in my linked list. Okay, so this was something I wrote. So credit card linked list has a GetIndex that takes an integer as a parameter. Here's that credit card, blah, blah, blah. Where is it? Where's my linked list? Oh, I'll call it linked list of credit cards. So here's my GetIndex. This guy takes a index as a parameter. We'll return a credit card, and this dude will just zip through my linked list until it gets to the right position and then return the credit card that lives there. That's what that guy does. So this is my linked list version of saying, give me the array at bucket 7. Okay, this starts at the beginning of, so this goes back to your original question. Start at the beginning of the list, zip up to the position in the list by traversing it one step at a time. So keep walking from Cur Node to Cur Node.getNextNode over and over and over and over again until I finally land on the guy I want to return, and then I'm going to return his payload. That's the credit card that lives at bucket index of my linked list. Okay? So that's what I'm doing here. I'm asking my custom linked list to get me the actual credit card that lives at this position. All right? So this is a pretty integral part of what we had to do here since we were building this custom array adapter in terms of our custom linked list, right? We had to teach it how to get the element from a certain position there because it didn't know how to call it like you do for an array. So here's my credit card. I'll go ahead then and use that credit card to fill in the pieces of information here, ultimately return the view. The next time GetView gets called, as long as it's after the first 24 times by our example, this guy will actually be a real value. He's already been inflated. So we will fail this if statement. We're saying, is list item equal to null? No, it's an actual row. It has some other credit card information in it, but it's already a row. We don't have to blow it up again. So we're just going to go ahead and overwrite the crap that's currently in there with the new credit card stuff.
I know you were explaining this, but like when you say inflate, that's pretty much just putting like dummy rows and it's just inflating it out.
No, so think about this guy. Where's my, is it? It's my custom credit card row. Yeah, this guy. Think about this guy as being like an empty balloon. All right, so this guy's an empty balloon, and we have 24 of them laying over here, right? So I have 24 of these balloons. I'm going to inflate 24 of these, and we're just going to reuse those 24 over and over and over again as we swipe through here. Each time through, I'll swap out the values that I put on them. Okay, and the reason why I say balloon, I'm using that analogy, is Android kind of supports that analogy by having this thing called a layout inflator. Okay, that is a dude who inflates balloons. You can think of that. He inflates views. All right, so you could think of this guy like a clown that walks out there and says, give me that balloon. I'm going to go ahead and blow that balloon up in this context.
It's like a deterministic push-down automata from last
Oh my god.
You think that makes more sense than my clown analogy? I need 24 balloons, right? Okay, I need 24 balloons to put my credit card information on. So if the dude just handed me an uninflated balloon, I'm going to go ahead and inflate it. After that, I have a bunch of balloons, and I'm just going to keep reusing them.
And as that's running through and you're getting more values, it's inflating it less and less balloons, correct?
Well, once you've, assuming by my example,
Right.
I'm saying that that Android has decided that you need 24 rows in order to maintain efficiency for scrolling. Once we've gone through this 24 times and done 24 inflations, it won't inflate anymore. It's just going to be handing me the balloon and saying, scribble out what's already on there and rewrite the new credit card information on it.
Right. I guess so. I'm thinking of each one of those these custom credit card rows, whatever. Is that one balloon, or are you thinking of all the rest of them that are empty?
Yeah, think of this as being like the mold at the balloon factory.
Okay.
So you buy a bag of 24 balloons all made from this mold.
Okay.
Okay, so I have 24 balloons that when I blow them up, they're one of these rows.
Okay.
That kind of makes sense?
Yep. And then so
Yeah. So this guy is like the prototype, the blueprint or something like that for the balloon. It's like an episode of How It's Made. Any of you watch that show? I watched like about 15 or 20 episodes of that. I say episodes of like skits of it on YouTube every night when I go to bed. It's amazing how some of the things you get to learn how to make. Like some things you didn't even know people made that.
like what?
Well, how do you make mushrooms? That was one I saw last night. Like we think of mushrooms as like growing in the ground and stuff like that. Well, you can't mass produce them like that. So they have to create the situation where the mushrooms will grow, and how do you harvest them and stuff like that? How do you make off the cob corn? That was one I saw the other day. They got these machines that take all the things and they cut it, they spin it through this thing that gets all the outside parts off, and then they go through this grinder thing that takes the corn out. Oh, it's like amazing.
You ever seen like a machine that takes cherries off of a tree?
Yeah, it shakes the tree.
That is so cool.
And along with that is they have I just saw that on maybe within the last month. Yeah, and then they have a pitter that these machines that hold the cherry there, just puts a stabber thing right through it and knocks the pit out.
That's great. I worked at a cherry orchard. It makes your fingers hurt.
It was really wild.
I once watched people working at a cherry orchard in bed in the last month on How It's Made.
That's awesome.
So I feel like we've had identical experiences, is what I'm saying.
I thought about bringing
VR?
I learned how to do a magic trick in VR the other day.
No way.
Yeah.
What can you do?
Do they have a rubber band? If you have a rubber band, I can do a trick with a rubber band.
How about a ponytail?
I don't know. Is it stretchy?
Yeah, it's stretchy. That's how I hold my bobby pins too.
Well, it's possible I can do the trick with it.
So you're touching my non-touchscreen monitor.
Oh, I lost it. All right. So,
Hold it up to your eye.
so it starts off. You hold the thing like this, and you say, okay, it's not going anywhere, right? So now you want to get it to jump between fingers there.
What? What the heck? I'm so confused. Do it again. What?
So then with the actual trick, so I learned how to do this all in VR. So then with the actual trick, then she does this thing where she takes like another rubber band thing and like creates like a wall across her fingers to block this thing from being able to come up and go back down. And she still does it. Still able to get it to work.
I was so confused.
I'm definitely gonna
See,
learn that.
I am totally. See, I'm magical, right?
That's a good funny
One of those
trick.
cool little things I can throw on my phone for
Do you want to see how I do it?
Yeah.
You just stick it under your other two fingers.
Yeah, so it's
You have it here and then.
it actually travels through time. So the idea is, so you have it on two fingers here. So you're showing the person, see, I can't go anywhere, and then you put your finger, you tuck your fingers like that, and then when you straighten them, it just pops over to the other side. Same thing here.
My wife's gonna ask me what I learned in grad school today. And I'm like, well, I can borrow a hair scrunchie.
I learned how to make a hair scrunchie go through. Is that a scrunchie? It's not a scrunchie.
Everybody calls it dick
Oh.
sometimes.
How to make it pass through my fingers.
I'll bring it
I
right.
call it, what do I call it? I call it twisty. Twisty?
All right.
Never called it that.
So we understand the whole balloon inflation thing. All right. What was I doing? This guy. All right. So GetView will get called every single time we need the next row. We need to show a row in our list view. We will blow up the balloon if we need to. Then we'll grab our credit card from our linked list. Then we'll set the values. Make sense? All right. That's what our custom array adapter does inside of main activity. We no longer now need to, last class I wrote this simple linked list of integers, right? Went and filled it up and showed you how to do that. All right, so I can go ahead and gut that. No longer have that. This was us just showing the linked list worked. All right, here was our collection of, well, actually, I need to leave the loyalty programs. That's the strings. No, I don't need to leave them. That's fine. No longer need that collection of credit cards. All right. So this is my credit card, and what I'm going to do for right now, I'm just going to take that out. I'm going to take that out. I'm going to take that out. So I'm only going to focus on the credit card list view for the moment. All right, so here's my credit card list view. I just grab it from my interface. Then here's my credit card custom adapter, which is my credit card adapter for linked list. This dude right here. And I pass it the context, I pass it my custom row thingy, and then I pass it my linked list, my credit card linked list.
Wait, what?
Now, no, I'm in main activity right now. This is main activity. Yep, and so notice here in core, I have my credit card LL, which is just a new linked list of credit cards with nothing in it. So that's an empty linked list that I have stored inside of my core instead of an array of 1,000 of those guys. So I can actually go ahead and dump my array of 1,000 of those. Okay, similarly, I can dump my array of 1,000 credit card strings, but we could have dumped that last class. All right. I also no longer need credit card count, because a linked list keeps track of its own count, right? Let's see. I am still using my adapters here, I think, for the moment. Actually, I'm not. I don't think I'm using either of those.
When you got rid of the counting.
I know there's going to be some errors down there. We'll dump them. We don't need it. Okay, so CC custom adapter. Yeah, here's my CC custom adapter. So I no longer need these two default array adapters. That's from 2 classes ago with strings. All right, I'm going to leave my loyalty program stuff in there for right now, but we'll be gutting that in a few minutes when we do the loyalty program side of this. Okay, so I just have my single CC custom adapter for credit card linked lists. Inside of main activity is where I set that guy right here. CC custom adapter is equal to an instance of my credit card array adapter for linked lists, and I pass it my empty linked list initially. All right. So for right now, I'll just go ahead and I'll just comment out the error here in loyalty program. We're not going to mess with loyalty programs here for a few minutes. We're just looking at credit card stuff. Okay, so when I add a credit card, I'm adding it to the end of my linked list here, right? I no longer have any arrays to maintain, so I'll just delete those guys there. And then I'll just let my custom adapter know that my data has changed. So inside of Core, I have a linked list for credit cards and an add credit card. That's all this. Well, I guess I have my custom array adapter just so I can tell it the data set has changed. Okay, that's all it exists in there for dealing with credit cards. Inside of my add credit card dealy flippy guy, that's green. Where's that? Add credit card activity. On submit button, what do? I read in the credit card name, the start date, minimum spend, bonus. I create an instance of credit card. Right now I'm still displaying it to the screen, but I'll go ahead and take that out because we don't need to look in logcat anymore since we have it populating inside of our list view. And then I call core.addCreditCard. And what does core.addCreditCard do? It adds it to the end of my linked list, tells the array adapter it's updated. Make sense? How all those moving parts work now? This is all adding a credit card means now. Add it to the end of my linked list. Let the custom adapter know that the data set's changed. The custom adapter was built in terms of my linked list. So now when I notify him that it's changed, what will happen? He will call getCount, which will return a length that's one greater than it used to be for my linked list. All right, so if I go ahead and run this guy, it should work for credit cards right now. But I've gone ahead and removed some of the loyalty program stuff. I like all the offerings I get.
Yeah, I know. I don't touch
It's
that.
like a worshiping false idols lesson.
Let this be a lesson. Negative sense.
Did you see my post today about the Bible homework?
I'm reading it right now.
Like in class?
Yeah.
You're sitting in my class reading the Bible homework?
Well, would you rather I be on Facebook?
Okay, I'm gonna give her. That's bonus points. That's a great response. What, would you rather be on Facebook? That was pretty good. All right. Whoa, what is that? Oh, my Zoom done something?
Just be honest.
I've created a monster.
Yeah, it's gonna be tough. No, there's something about not posting or something. Yeah, a little bit. There's bits and pieces. It's a really small chapter.
Yeah, it really focuses on incest. So. All right, so I go add a credit card. I'll just put in some stuff, 3,000, bonus points, whatever. Hit submit. That gets added to the end of my linked list. Now it's in my row here. All right, so originally, as you pointed out, it showed 0 things. Now it shows 1 thing. If I add another thing, blah, blah, blah. Now it shows 2 things because my linked list now has 2 things in it. Make sense? Okay, so what we need to do now is so that's me explaining what I wrote for you. Okay?
Great job.
Okay? I just explained what I wrote for you. And then we gutted a couple of things here to simplify core and things like that. So now what we want to do is we want to go ahead and we want to write a linked list of loyalty programs, right? And this guy is going to have a length, it's going to have a GetIndex, and it's going to have an addEnd. Now, a good, let me ask you this. How many of you sat there and made sure you understood what my code did before you started doing your side of the homework?
Try as best I could.
All right, follow up to that. How many of you tried to write linked list of loyalty program without looking at linked list of credit cards? So you should have at least tried to see if you understood the concept of linked list.
The errors are scary.
The add-end stuff makes sense.
All right, so I'm going to create a new Java class. We'll call this guy linked list of, what's this, loyalty programs? Oh. All right, now I'm also going to need a, somewhere in here I have a credit card node, right? So we're going to need a loyalty program node, kind of the equivalent of this guy. So I'll also create a new Java class, loyalty program node.
I think like I didn't spend too much time going over the linked list stuff only because it just looked familiar. Like it wasn't something I didn't know. Whereas that linked list, the array adapter for linked list, I spent a lot more time looking at that because I was like, what the heck is going on here?
Right, but there's two sides to it. One is it looked familiar, but at some point you're not going to have me sitting there to write it for you. Right, so you're going to need to be able to. Well, not every one of you will be able to do it, but you know we'll need to do it on your job, I guess I'd say. But putting together a quick linked list is something that should be a relatively trivial.
Pretty close to Hello World, like people.
Above Hello World, above Hello World.
A pseudocode version of a linked list.
Should be pretty easy. Yeah.
So know how to do linked lists.
Well, and stacks and queues and binary trees. Those are all fun things. And you'll actually probably find that in some of your job interviews for computer science stuff, they're going to ask you to write some code that does some different stuff. I mean, sometimes you'll have a job interview where they don't ask you any technical questions. Other people have job interviews where, you know, they come out crying because they're like, I left the test blank, basically. Didn't know how to do any of it. All right, so this is our loyalty program node. So nodes all have, so we'll have a private loyalty program node next node. We'll have a private, and our nodes are going to hold loyalty programs, right? And we'll call this guy payload. So a node holds a payload, a node also knows about the next node. Okay, so we'll create our constructor here. So we have our public loyalty program node. This guy will take in a loyalty program payload. We'll say this dot payload is equal to payload. We'll say this dot next node will start off as null, because initially when this guy's first invented, when he's first born, he's not going to point anywhere. All right. We want to be able to get the payload. We want to be able to set the next node and get the next node, right? So we can go ahead and right click and do our getters and setters thing. Where's that generate? So I'll do generate getters for both of these dudes. And then I'll do a setter for next node.
And you said last week this is implicit in these methods. Like this, when you're doing the getters, it's return payload. So when you're doing that, you don't need to preface it with a this, like this next node or the payload.
You don't, but if I were writing these myself, I always would.
Okay, so that's what I was asking. That's implicit in these methods.
But since you brought it up, And he's not allowed to answer because he answered it last week. Why don't I need this dot? Why is it optional here?
Context.
Do you know why that is, or you just remember him saying context last week?
I remember saying context, but the context of this will be an instance of a node.
Okay.
So,
How do you know? How do you know that this guy is a
because it says public and there's no static on it.
perfect? Yeah. Since it doesn't have static, this guy is a non-static context, which means he has access to all of the instance stuff of Node, which means he has access to these dudes here, right? It is never wrong to put this dot in front of these. In fact, very often, and here's the perfect example, if I'm taking in a payload and I'm storing a payload, it makes pretty good sense for those two guys to have the same name, right? That's why you need this dot payload here and just payload there. I can say payload equals payload. It's not going to scream at me. I'm just not doing what I want it to do. I want it to set this instance's version of payload equal to the most local definition of payload. So bottom line is you will never be wrong if you always say this when you mean this. When you're talking about the stuff owned by an instance of this class, always say this and you won't steer yourself wrong.
So what's the static keyword do? Turns it into, I know
That makes it a static context, which means that the thing only exists once and it's owned by the class. So a payload exists one time per instance of loyalty program
I
node.
understand that. So
If I made this guy static, payload exists one time ever. No matter how many times we have instances of loyalty program nodes. You would always access this guy by saying loyalty program node dot payload.
would that static payload be accessible in all the instances?
Since it's not right now, actually, it would be in all the instances within it because it's inside this class.
Right.
So yes,
So public static can be accessed anywhere in the program, but can only
public static can be accessed anywhere. Private can only be used inside of that class. So a loyalty program node could say something like loyalty program node dot payload. He's allowed to access that guy there because it's private, it's static. Static means I need to call it with the name of the class. Private means I can only access it inside of this class, and I happen to be inside this class
so it'd
right
be
now.
like a global variable for all the instances of the class.
Something like that. If that happens to be the tool that you need.
And the reason you wouldn't want to do static is so you can use the same variable name other places for different things?
Well, no. I mean, if you look at this picture, don't we have several nodes here? Here's a node, here's a node, here's a node. Shouldn't each of them have different payloads?
Yeah.
Yeah, we don't want just one payload.
Gotcha.
We want each guy to have his own copy of the payload.
Okay, so in other words, you can't have a different value for that.
Yeah, if it's static, we got one value.
Value
Yeah, it
and-
exists once.
Okay.
Yeah, so think of it like a factory.
Okay.
You know. Okay, so this is our loyalty program node. We build it. We have the ability to set the next node. We have the ability to get next node and get payload. I updated these guys with a this dot. It's not required, but if you're not going to write it, make sure you understand why you're not writing it. Or because you're using the built-in getters header thing. I don't care that much, just a reasonable reason to not do it isn't because, oh, it just works this way. Okay? That's not an acceptable answer. You should either be able to explain it or write it in the way that you can explain. All right, so loyalty program node. Did I already create my class for loyalty or linked list of loyalty programs? I can't see any of this. Ah, I zoomed way into that for you. Hold on.
The other one was good.
Well, yeah, I couldn't see it up here.
Itself, but it's the tabs that are
the tabs that I can't read.
Yeah, the tab. I can't read them. I have to get one of those monocles.
Rebate key.
I'll look over.
Totally, I need. I will totally start using a monocle.
That'd be awesome.
Do you look right now?
It's not our rebate key. I look. All right, so linked list of loyalty programs. This guy will have a private and we're doing it. This is a linked list of loyalty program nodes, right? So we'll have a private loyalty program node called head.
That's what I was looking
We'll have a private int count or length. I don't remember what I called it in the other guy. We'll have a public linked list of loyalty programs constructor. This guy will say this dot head is equal to null. This dot count is equal to 0 because there's nothing in it yet. All right. Then we'll say we need to add something to the end, right? Actually, we need length. Isn't that what I called it? Length? I think public int length like this. This guy will return this dot count. So there's length. All right, then we need add end and then GetIndex, those two guys. So public void add, is it add end or add at end? What do we call it? Doesn't
Java
matter.
class says add last, add first.
Yeah. Well, you cheated, looked at the Java class?
You bet I did.
Exposed.
I figured
Yeah,
I'll
maybe.
see how they do.
And now that you've seen me write the linked list twice, maybe we'll have a quiz in the second thing. Write a linked list of chars or something.
I just
Just
wanted to see what names they use.
sit back and laugh.
God.
Well, she'll just sit back watching. It's like, oh, I thought that was like a big like orange juice bottle. What are you doing? Making breakfast and reading Facebook. What do you think I'm doing? Shut up and teach. All right, so add in. This guy's going to take in a loyalty program payload. All right, and we are going to go ahead and build a new, what do we call it, loyalty program node. LPN is equal to a new loyalty program node, passing it that payload. So now I have my loyalty program node. I'll ask the question, if this dot head is equal to null, that means I have an empty list, so I'll just say this dot head is equal to LPN, and I'll move on with life. I do need to make sure I say this dot count plus plus there at the end. There's one way or another I'm going to be adding something to this linked list, right? So I want to add to the end, build my node. If my list is currently empty, go ahead and make the front of the list point to this brand new dude. Increment count. If the list is not empty, I need to move to the last dude in the list, right? That is, I need to move to the node whose next node is null. So I'll say loyalty program node Cur Node is equal to this dot head, while Cur Node dot get next node is not equal to null. Cur Node is equal to Cur Node dot get next node.
So when it's talking about if the head is equal to null, is it talking? So when we're looking ahead to on the nodes, is it just saying we're looking ahead and see if that's null, or are we are?
Head points to something. If you look at this picture here,
Yep.
when I first build that list,
Yep.
head's like that. It's pointing nowhere.
Okay.
So if head points nowhere, and this is my very first node I just created, this guy right here. So this guy, this node, when he's first built, he has a payload, and he has a next node that points nowhere. If the head is pointing to null, I just make the head point to that guy. Then I'm done.
Got it.
But if head points to a real thing, and I am placing this dude, let's say, I need to get myself positioned at this guy so that I can make him point to my new guy.
Got it.
So that's what this does. This starts me off at the beginning of the list. So in this else, that means we are dealing with not an empty list. Then I zip up to the place, so I keep going as long as Cur Node dot get next node is not equal to null. So I keep going as long as this dude's next node
It's not null.
is not null.
Got it.
In a one list, right off the bat, he's already null, right? So I have my Cur next node or Cur loyalty program, whatever I called it, Cur Node. I started off pointing to the same place as head, and right off the bat, he's already pointing to something where the next node is null. So he's already exactly where he needs to be. So I say Cur Node dot set next node to LPN. Tack it onto the end. So I either just set head, I make head point to this guy in the event it's an empty list, or I run to the last node in the list and then make that guy point to my new node. All right, so that is add and end. And then any way you cut it, my count goes up. Make sense? All right, notice that's outside of the if and the else. So one way or another, I'm adding this guy to the list, count goes up. Last guy is, what was it, GetIndex, and it returns just the payload, or does it return the, no, it returns the actual, no, payload, because it returned the credit card in the other one. All right, so this guy will be public loyalty program, GetIndex, and this guy will take in an int index or int position, whatever I called it, or whatever you want to call it. All right, and this guy's going to return a loyalty program. We don't have to do any error checking here. We can just assume that the index they passed in is a legal index in here. So I'll go ahead and say loyalty program node, Cur Node is equal to this dot head. I'll write a little for loop. For int I is equal to 0, I is less than index, I plus plus, and we'll just say Cur Node is equal to Cur Node dot get next node. So that will sprint him down the list, hopping from node to node to node to node until he's standing on bucket index. And then I'll return Cur Node dot get payload. Make sense? All right, so that's our linked list of loyalty programs. Wouldn't call it a full linked list because we can't remove stuff. We can always only add to the end. But in terms of what we need right now, this pulls it off. Okay, now I need to create my array adapter, right, for my loyalty program. I also need, let's see, what are loyalty programs? What do they have in them?
Only 3 things.
Okay, so I need to make a special awesome row for that guy. So we're going to go into layout here, create new. I'm doing a layout resource file, and we're going to do loyalty program custom row, and I'll set the root element to linear layout here. And then I'll hit OK. That's this dude. And how do we want to, it's the name, the bank, and then, okay. So this guy, do I already have it? Is he already vertical? He's vertical already. So we'll just do 3 text views on top of each other. And then we actually probably want to label those guys. So I'm just going to do this. I'm going to create a horizontal linear layout. Throw that in there. Then I'll put a text view in there and another text view in there. We'll make the first text view say program name, and we will have the this guy is going to hold the program name, so we're going to call this guy LP program name TV. We'll put, actually we can just give it a placeholder for right now. We'll say like, you know, Chase Ultimate Rewards, something like that. Okay, so I'll just do a horizontal linear layout like that. Now I'm going to copy that horizontal linear layout, and ooh, that's pretty ugly the way that pasted in there. All right. So I'll put 3 of them in there, and I need each of these horizontal linear layouts. I want the height to be wrap content. And so the first one is program name, and that's LP program name TV. The next one, this will be bank name. And this guy will be called LP bank name TV. Oop. And then this guy, where's my stuff? See, sometimes you gotta wiggle it until it. All right, and this is gonna be current points. All right, and this guy will be called LP Points TV. All right, so I'm going to resize this guy until I get it to kind of a place that, so we call the width of that to be, am I on the wrong thing? No, that's right. No. Oh, he doesn't like the fact that I have all these extra IDs. Since I copied and pasted it. I don't even need IDs for those guys, because I'm not going to directly access them. Alright. Now I think I should be able to change the size of this guy. We're going to do it with layout weight. So I think I can do 33. Is that the way to do it? Say that looks decent. So these will all be 1 to 10, or what did I put it at, 20? Oh, it's still based on the size. All right, I'm gonna stop screwing with it. We're just gonna say it's fine. I don't need beautiful interfaces. So that's 1, 1. This is 1, 1. This is 1, 1, and we'll set all of these guys up to wrap content. going to say that's good. All right. The first one is program name. Second one is bank name. We'll just put like Chase in there. And this last one is current points. So I'll put in like, I don't know, 100 or something just as a placeholder. All right. So that's what our row looks like. And we named this dude loyalty program custom row XML. All right, so just for the sake of time here, let me just quickly grab the code from my credit card array adapter for linked lists, and I will just modify it quickly for our array adapter, loyalty program array adapter for linked lists. I'll create a new Java class, loyalty program array adapter for linked lists. All right, and go ahead and steal that, paste this. All right. So, and this guy's going to take in a linked list of loyalty programs. This would be a linked list of loyalty programs. And we'll call this our loyalty program list up here. Actually, I can show you something interesting here. So, so this guy's currently called credit card list. If I highlight that and I right click, there should be something in here called refactor. So if you go to refactor and then go to rename, this is a software engineering thing. So this is going to be a loyalty program linked list. You see it change in all the other places? You wish you knew that before? So, yeah, and a lot of times, so I mean, what I'm showing you here is more like a convenience tool, since I'm trying to zip through this real quick so we can take a break. But you know, the one thing I will sometimes do, just so I can see where it causes errors, is I'll break a variable up here. So I'll take the T off of that, then I can see all the places in here where it's used.
How do you get it to edit all of them again?
If you highlight this, and you right click, and you say refactor,
Okay.
and then choose rename, then when you rename it there, it'll change it in all other places where it's being used.
Something I was doing is when I was clicking on something like loyalty program link list, I was like, I want to see where it's used. I would click on it, then I'd find usages.
Yeah.
Like, how does that work, though, necessarily understanding what it was doing?
Well, if I click on this, I think it's what, like show usages or something like that?
Find usages right there.
Yeah, so that'll show me all the places in my code. So this is where this guy is being used. So let's see.
It shows on the
Yeah, there's 2 usages inside of here. 1 usage in get count.
Okay, so it's just like, it breaks it down for the whole program.
Yeah. All right. So let me hide that. Hide this. All right, so that looks good. That looks good. Come down here to get count. That looks good. Here's my get view. That looks good. Now I need to change. I have 3 text views here, right? So I have LP name. I have LP bank, and I have LP points. There's my LP points. I no longer have this 4th text view. I'll go ahead and get my loyalty program call that LP, and that'll be my loyalty program from a certain place. So I'll say LP name is equal to LP dot. Oh, I don't have getters for loyalty programs yet. So I have private name, bank, point balance, and I don't have any getters. So good thing is we can right click and say generate getters, select all three, and there we are. So we have our getters. Now I'll go back into my link list. Where'd it go? Loyalty program array after this guy. So now it's lp.getName, LP bank is lp.getBank. LP points is lp.getPointBalance. We no longer have this dude. Return the list item. So this array adapter is now done. Go back into core. We'll just update core real quick while we're at it. So we'll add our link list for loyalty programs. So this is a public static link list of loyalty programs. The loyalty programs LL link list of loyalty programs. Then we'll dump our array stuff. And our loyalty program count stuff. All right, then we'll give ourselves our custom adapter here. So public static loyalty program array adapter for linked lists, LP custom adapter. All right, then adding a loyalty program, we will dump these three things. Yep.
We don't need our other array adapter anymore then?
The original array adapter?
Yeah.
No. Yeah.
Because we made our own now.
Yeah, the credit card one for linked lists and the loyalty program for linked lists are the only two we actually need now. Okay, so add loyalty program is going to mean calling my array adapter. So core dot the loyalty programs LL dot add end LP. So we'll add that dude to the end, and then we'll say core dot LP custom adapter dot notify dataset changed. So same two things I did in my add credit card. Okay. Go back to main now. We're just about done. So here is my loyalty program list view. Still need that dude. I no longer need my CC adapter dude thing here. I'll go ahead and create my custom adapter for this is LP custom adapter is equal to a new loyalty program array adapter, passing this guy the context, passing it r.layout dot loyalty program custom row, and then I need to pass him my linked list. So this is the loyalty program LL. All right, so that's my LP custom adapter. Takes all those pieces. And then lastly, I will set this dot loyalty program LV dot set adapter to my core dot LP custom adapter. All right. All right, then we hit play. And working theory is we should now have 2 list views with nothing in them initially. And if I go to my loyalty program, Chase Ultimate Rewards, name of bank Chase, we'll say 100 points there, say submit. All right, what did I do in my add loyalty? I never actually looked in that class. Add loyalty program activity. Here's my loyalty program. Here's me telling it to display itself. We'll get rid of that. We don't need that anymore. Core add loyalty program. That looks fine. Doesn't seem to be complaining about any of my stuff. Let me try running it again. Oh. I wasn't looking at everything very well there. Let's see if we can get the name of it better now. Line 49. LP.get. Oh. It's got to be a string. You can't set it to int. Now it works.
What was the other way of doing that? I remember you mentioning, aside from doing double quotes, is there another way to cast an into a string in Java? Or is that the only way?
That's the way.
No way? Okay.
All right, there's my loyalty program triple stacked. There's another triple stack, add a credit card. All right, so that's the whole homework assignment. And then we've gone through, we've cut down some stuff, so we've streamlined this guy a little bit. All right, so let's take about a 30-second break. And let's take like 10 minutes. And I'll get this uploaded.